Thanks. Yeah, glad to be here. Let's talk about, if not my favorite topic, at least the one I've been talking about most recently, rich text. Before we get started, I'm kind of curious, like how many people out there have tried to implement some sort of rich text editor before? Cool. I see like the trauma in your stares. So you kind of know the struggle. Yeah, working on Lexical has been an adventure, and yeah, excited to kind of share it with you guys. So let's dive in. First, just a little bit about me, I guess. Actually, most of this is really already been covered. But I'm a software engineer at Meta. I lead the Lexical core team. Lexical is an open source text editor that Meta recently released, and that we use internally, externally, on all of our not all of our products, a lot of our products. And there are a couple things I've listed here that if you ever use Lexical and you just really, feel yourself infuriated by any of these things, then you could actually, legitimately, personally get mad at me about those. So just keep that in your back pocket. So what is Lexical? Three big things here that I think kind of represent it. One, it's a library for building text editors. That's kind of the practically what it is, right? And I would kind of call it the distinction there between a library for building text editors and an actual rich text editor. There's kind of a distinction there between something like Lexical and something like TipTap, for instance, which is really just like a full-fledged editor, has a lot more constraints, doesn't try to do as much out of the box, or does more out of the box, imposes fewer constraints and more constraints and has less flexibility. Lexical is really made to do the opposite. It's made to give you a toolkit for building rich text editing experiences on the web. So you could use Lexical to build something like TipTap. At the same time, like there's not a really huge, that's something that we needed at Meta. It's not something there's not a huge market for that necessarily. What people really want is like an easy way to build a rich text editor that will, that they can use on their website for their customers, for their users, whatever, right? And so while it is basically a toolkit for building text editors, we also put a lot of effort and time into trying to build useful abstractions that you can really just kind of grab out of the box and use to build those experiences that you want to serve to your end users. So that's kind of the goal there. It's a core piece of Meta infrastructure. I kind of alluded to this earlier, but we use it in a lot of places. It's pretty battle tested. We're kind of experimenting with it constantly at the edges, trying to push the boundaries on performance, trying to push the boundaries on like what we can do developer experience wise. And we'll get into a little more of that later. But yeah, like it's something that we've been using a lot and that we've been pretty happy with. So third, it's a community. So, this is kind of my first really major foray into open source, to be honest. And it's been really one of the more fulfilling parts of it has been kind of seeing the community evolve around this and seeing like people that are willing to come in and like point out your flaws and also help fix them and also point out your typos and help fix those. And so like it's really been a community. We are really active Discord, a little less active on Twitter, more active on GitHub. But yeah, there's a lot going on there, and I feel like it's helped push the rich text conversation forward on the web. And so I've been really stoked on that. But that's in a nutshell what Lexical is. So the next question is usually why. Why did you guys do this? I think I have some examples here. There already, we have Slate. What's that? Prosmere. I think this is Quill. There's Draft. That was ours. We made Draft, and and then subsequently replaced it. So there's already tons of effort and work's been put into developing good rich text experiences. So kind of why make a new one? And really they are all great. We're not looking to replace or supersede anything besides, I guess, Draft.js. We don't really have two rich text editing frameworks at Meta. So we did end up deprecating Draft. But other than that, like we're not trying to like say, hey, this is better than Prosmere or better than Quill or Slate or whatever. It's just a different approach, and we feel like we have some unique things to contribute that are going to push the conversation forward around rich text. So that's really kind of the motivation. And to be frank, we mostly did it for ourselves. Like we had a need. Draft.js wasn't meeting those needs. We had problems around around code size, around, developer experience, typing performance, accessibility was a nightmare. And I use accessibility kind of throughout this presentation to refer broadly, I guess, to basically being able to build user interfaces that are usable by everyone, as usable as possible by everyone, right? And so it's not just like literally, does it comply with WCAG standards? Does it work with JAWS? Does it work with Dragon? It's more about like, can someone using an Android keyboard, to write Korean use it, right? Like there's just like a broadly defined accessibility. Can you use the product kind of no matter where you're accessing it from and who you are and what your, abilities are. And so, we put a lot of effort into trying to make that work, and we saw big results. Some of the like accessibility, 74% without having like the internal details is kind of this is all relative to Draft.js, by the way, but which is what we're using at the time. But the 74% accessibility is kind of a weird number. It's kind of weird to quantify it that way. But we actually did, the reason I put this in here, we did really rigorous analysis around what were the blocked flows that we had with Draft.js, like what tools were users trying to access our product with, our text editors with at Meta, and where were they failing? And so that's kind of how we got down to this number. We identified the block flows, worked with third-party vendors, and we we developed a solution that unblocked those flows. And so, in terms of performance, this is specifically related to typing performance. And so we saw a huge win there. And then code size reduction as well. We were able to, and I'll dig into a little bit about the why behind all this later. But so we saw some pretty significant wins with Lexical, and thought it was kind of worth sharing out. Another thing to call out here is like when evaluating alternatives, we didn't really have like if we had adopted something else, we wouldn't have the flexibility to kind of go in and tailor it to our needs, right? To do the things that we wanted to do. If we wanted to optimize performance, if we wanted to make it, change things to work in a certain way to be, more accessible or whatever, that would be really hard to do with just adopting another external project. And so there's constraints around that as well that we had to think about. So moving on, kind of thinking about the design considerations. So this whole thing is about like the design of Lexical, I guess. And so I wanted to talk a little bit about what were the big things that we were thinking about. And also want to note that I'm using the term we pretty generously here. I was brought into the project 4 or 5 months after it started. And so some of these decisions really predate me and context I've gathered afterward. But I think it's worth sharing. So I was going to kind of go through that. First of all, we made it framework agnostic. We needed to have full control over rendering and input handling. And that kind of goes back to some of the accessibility things I was talking about earlier. When you're dealing with input methods that are kind of, I'll say unconventional, but things like, IME, Gboards, Grammarly, speech to text, all those kinds of things. You have a lot of issues that can come up with when you're tied to a framework that are gnarly, honestly. And so to get full control over that, that was one of the problems we had with Draft.js. It was tightly coupled to React, and we really couldn't get down into like I guess technically at Meta, we probably could have done something with the React team over time, but that's the feasibility of that solution is questionable. The best solution for us ended up being to try to develop something framework agnostic, which has other benefits as well. So the core library is just written in vanilla JS. It doesn't have anything about React. It doesn't have anything about anything. And we'll get into like a little bit more of the details on that there. Full control over the bundle size. We wanted to be able to like have, well, exactly what I said, right? Full control over how much code we were shipping to clients and what the footprint of the library was. And it's hard to do that when you have dependencies that you need to make the library work. So we wrote it completely dependency free. The core library is dependency free, and so you don't have to have immutable JS or anything like that, which is what Draft used. You can just software update. Hang on. All right. So you can just you can use the core library with no dependencies, and that gives us a kind of a lot of control. So reliability, that was a priority for us. We had one stat I didn't include on the last slide was kind of the huge reduction in error rates and crashes that we had, which, one of the things that we wanted to address when we did this is we want to make something really reliable. And so sort of the double buffering and state immutability architecture that we'll dive into a little bit later really helps with that. We can always like fall back to a previous editor state if we fail to make an update or commit it to the DOM. Extensibility. So that was another thing we were thinking about is like, how can we build an API that's limited in complexity and surface area, but it's still powerful enough to allow you to build basically whatever you want. So it's about like very simple core APIs in a lightweight like central library, and then useful abstractions built out around that to actually like add the functionality that you would need to make most rich text editors. And I'll talk more about that later as well. Cool. So basically how it works, right? This is just a very broad overview, and we'll get into more detail, I promise. But create a lexical editor. So you instantiate this thing, right? This editor. You attach it to a content editable in the browser. You tell it what content editable it's going to be attached to. You listen for user events, and then you update the editor state, and then I guess profit. I mean, I've never seen that part happen personally, but theoretically. Right, and so this is what that looks like with some code. It's a little more complicated than this generally in practice, but just like literally what I just showed you, this is it, right? You have an element. Let's assume you have an element in the DOM with the editor ID, and its content editable is set to true. You instantiate an editor. You attach it to the content editable with this set root element API. Add a DOM event listener, and then, if the user hits the enter key, then you run an update, you insert a paragraph. And that's pretty straightforward, and it's definitely an oversimplification. But just to kind of illustrate the concept, that's what you're doing here, right? Like you're just creating the editor, attaching it, listening for events, updating the state, and then Lexical takes care of the part where we're reconciling that new state to the DOM. And most people in reality are going to be using various abstractions, and you won't be dealing with, actual DOM events very often, or even like these create editor APIs and stuff. And I'll show you those abstractions later. But that's how the very basic core is designed. So core concepts. These are what I think of as the sort of fundamentals of Lexical. And we'll go through them one by one and kind of elucidate a little bit, I hope, how this all fits together to make the design of the architecture that I alluded to before and power a rich text editor. So editor state is a serializable representation of the current state of the editor. And at any given time, there could be potentially two, right? There's an active editor state and a pending editor state, and we'll go into that more deeply later. Nodes are discrete pieces of editor state, and so they kind of represent like text or a mention or like a paragraph or anything like that would be a node, and those are kind of your state is comprised of a tree of these nodes, and we'll see some visuals on that later too. Updates, just the process of applying changes to the state. So we kind of showed that before in the code. Transforms, this is a little more advanced, we'll get into that later, but that's the process of acting on an ongoing update. Listeners are just hooks for responding to events in Lexical, and then commands are our own like internal pub subsystem that introduces sort of a concept of priority to allow you to intercept and change how events are handled through the system, and we'll go into that more too. Right, so editor state. I'll give you a second to kind of digest this, but this is editor state is basically, it has a lot of other properties on it besides what you see here, but the fundamental piece of it is you have a node map. Nodes have keys, and nodes are classes, and they have properties, right? So like, and really that's, there's not, a whole lot more to it than that. You have, for instance, a text node, which has, text, which is foo. Mention node, this is mentioning Rick Sanchez. Hashtag node, you can kind of see. And you see the element nodes, which we'll talk about what element nodes are later, but they have children. And so the paragraph node 1 contains text node key 3, mention node key 4, and there's a separate paragraph that has number 5 in it. And so this is what you're kind of doing when you're updating state. You're changing this using not directly, but using APIs that we provide to kind of manipulate that tree. You'll see also selection at the bottom. So we abstract over selection. If you've worked with this stuff a lot or at all, you'll probably notice that there's differences in how selection's handled between different browsers. Lexical abstracts over selection, and we keep track of it ourselves, and that allows us to smooth over a lot of that stuff within the editor. So another way to think about this is as a tree of nodes, and so that's actually for me usually a better way to like represent it. And so that's kind of the same editor state. I left off like the keys and everything, but and the children property because it's kind of represented in the structure of a tree. But you can see you always have a root node, and then in this case you have 2 paragraph nodes, and then they each have their children. And this is obviously super simple, but that's conceptually what it looks like. I was hoping I could switch over. Just going to show you what it looks like on. So like this is that same state, and you can see here, this is where the this is like a debug view, and you have like the tree here that I mentioned before. But this is how that same state. This is how Lexical is rendering that to the DOM, and you have like 2 paragraphs, and they have just different nodes in them. So let me switch back. Cool. So let's talk about nodes. Like, what are nodes? I mentioned before they're sort of discrete pieces of editor state, and they encapsulate the behaviors that are important, like how serialization is one, how the element should be rendered or how the node should be rendered. Its behavior with respect to other nodes, what happens when you type text before it or after it, things like that. There's a lot of these. But here's just like kind of this is about as simple of an example as I could create. And this is hashtag node, which we kind of alluded to before. And conceptually, like for our purposes, at least a hashtag is just a text node that has some different style applied to it, right? You put a hash in front of the text, and all of a sudden it's like has a gray background, right? So we'll kind of walk through this code and see how that's implemented in Lexical, because there's a couple other interesting behaviors that we've added. So the first thing, and kind of the most obvious thing, is we override create DOM. And so every node has a create DOM method, and that's governing how Lexical renders it to the DOM. And in this case, we're just delegating to the superclass, which is text node. And then we add a special class to it. It's hashtag, which is from our theme, which is a separate concept we'll talk about later. But it's basically it. We just do whatever the superclass does, which happens to be rendering a span tag, and then we add a class to that, and that gives us a hook to style the hashtag node differently the way we want it to be. So the next thing, this is sort of like one of the behavioral changes I alluded to. There's a method called can insert text before, and this is like a thing that we use elsewhere in the code to determine when someone inserts text before this node, what happens. For some nodes, you might want to add the text inside the node if it's at the boundary. For other ones, you might not want to do that. And this is one where you actually don't want to do that. If you add text before the hashtag, then it's no longer a hashtag because it doesn't start with a hash anymore. Is sort of that's how it works here anyway. And so that's what this is doing. So that's sort of an example of one of those behavioral changes that are controlled by these methods. And isTextEntity is the same. It's a little bit more complicated to explain, but this is doing basically the same thing. You return true here, and that's going to change. It's going to cause this node to be treated as what's called a text entity elsewhere in Lexical. So when we're doing other things like handling user events like text insertion, deletion, things like that, we might have checks that are like if isTextEntity is true. If node.isTextEntity returns true, then do this thing or do that thing. And so that's kind of the basics of how you would use, overriding methods and extending the classes to build new nodes. And this is one that we have in the core, I guess, hashtag node. But this is built so that, and what people do a lot of the times is they further extend these nodes. So we have people that take like link node and extend that to make some different variation on link node. And that's kind of what this is built for, is for you to do that. One more thing on nodes, they come in kind of two flavors, elements and leaves. So the really big difference here is just that elements can have children and leaves don't. And so there's kind of a pretty clear separation here. When you conceptualize elements, you can think of things like block, kind of like almost like analogous to block level things in the DOM. It's like, paragraphs would be one. Quote, we have like quote blocks, code blocks, things like that would contain other nodes within them. That's what an element node is. And so you can extend element node, or you can extend text node, and you can extend also one other called decorator node. But those are the three that we expose for you to extend. And they have those are the big behavioral differences, really. So I sort of alluded to this already, but like updates are the way that we apply changes to the editor state. So this, I guess I moved into the update section without really realizing I did that. But so here we are in the update section, and I've alluded to it already, but like this is pretty much how it works. You have an editor, you call editor.update, and the reconciler takes, you apply some changes, the reconciler takes care of applying those changes to the DOM, and then swapping out the editor state for the new one. And so like, you can think about it kind of like as you call editor.update, you pass it a callback, and then in that callback, you can change the editor state however you want. It provides you with access to the active editor state through the lexical scope of editor.update of the editor itself. And so inside that callback, you can make all the changes to the editor state you want, and then Lexical is gonna build a pending state from that, and then reconcile those changes against what's in the DOM, and then make that pending state the new active state. And so at a very high level, that's how updates work, and we're going to go into a little more detail with this on this kind of life cycle. So as a performance optimization, it's not usually just one update. I mean, it can be for sure, but Lexical typically batches updates. So you can imagine like sort of a complex application where you have different things going on, different listeners are firing asynchronously and calling different updates. Lexical is going to try to batch those. So if we get an update call while an update's ongoing, then we'll just queue it. And eventually we'll go through the whole queue of updates, and we'll apply all those, and we'll do one reconciliation to the DOM instead of doing like update, patch the DOM, update, patch the DOM, update, patch the DOM, which is slower. So the next thing is sort of as we're going along and updating, right? We're making these changes. Lexical keeps track of which nodes are dirty, like which nodes have been changed and therefore need to be reconciled. So we're really interested in like, if you kind of think back to that tree, we're really interested in like which subtrees do we need to apply changes to a DOM for. We know there are certain ones that in most cases we can just ignore. And so as we're doing these updates, then we're marking different nodes and elements as dirty. And then once we get to the DOM reconciliation part, we're only going to reconcile and commit to the DOM changes that are for dirty subtrees, basically. Also during this process, we're sort of like, any nodes that become detached, like let's say you like delete a node or like you remove it from its parent or something like that, we just go through and garbage collect all that and free up the memory. So that's another thing that kind of happens during this process. Fun fact, I guess it seems kind of out of context, but like the reason why we called it lexical, well, part of the reason is kind of the double meaning between, like the dictionary definition of lexical meaning relating to the words or vocabulary of a language, and then sort of like the way we provide access to the active editor state through the lexical scope of the update method on the editor. And so we thought we were really clever with that name. But so let's talk about transforms. We kind of talked about updates before. We talked about batching. One thing that started happening to us early on, we were developing this, is we would do an update, and then we would basically want to do another update based on that update. So it was like you can imagine like the user types the hash key in front of some text. And now you want to turn that to a hashtag node because it's like it matches the hashtag pattern. But in order to do that, we have to wait for Lexical to finish the update. And then in an update listener, we have to read the new state, go through all the text nodes and say which ones have hashes. And then we have to change those into hashtag nodes. And that's super inefficient. It turns out you end up with like waterfall updates. So you basically have like an update. Then when it finishes, you check and you update again based on the new state, and then you update again. And so that's not super awesome. And so what we introduced to solve that problem is this thing called transforms. And so the way transforms work is when you do an update, before Lexical actually commits those changes to the DOM, it leverages the fact that we've already built a list of dirty elements and dirty leaves, which you can see kind of a reference at the top there. And you can register transforms for specific node types. And so basically, let's say in the same example I just gave, when you have a text node that you put a hash at the front of, then Lexical would trigger transform listeners for text nodes and say, hey, these text nodes all changed. And then inside that transform, you're able to go in there and say, okay, this text node changed in such a way that it should now be a hashtag node. And you can make that change in the transform and before Lexical actually commits everything to the DOM. So you kind of have like a hook to say, I want to respond to changes in the editor state without waiting for everything to be committed to the DOM, and then react to the new state. So you kind of stay in the same update cycle. We can look at a real world example of that too. So I think this is hashtag node. So this is the one that I just, we've just kind of been staying on, right? Hashtag node. And so really good example of a transform where you would register it like this. You say, I want this transform to run for all text nodes. And so when when update occurs and certain text nodes are marked dirty, then this transform will run for every one of those nodes. And so what we say here is like, if it's a hashtag node, then don't do anything, right? But if it has, text, this is super naive, by the way, but if this has a text content that starts with a hash, then just replace that node with a new hashtag node with the same content. And so that's pretty straightforward. And this API is like, it seems like what would you do with this besides make hashtag nodes? But we've actually found that the applications are pretty broad, and sometimes like people would do things with it that were like, maybe you shouldn't. But that kind of goes back to the flexible and powerful nature of the APIs. And like one example of that, we've also used this for like auto links, mentions, which are kind of like hashtags in a way, emojis, things like that. But people have also used it for one example I can think of is that there was someone who wanted to disable just like the bold feature for their editor and keep all the other features. And we don't really expose like an API for just disabling specific feature flags or whatever. And so what they ended up doing was just making a transform that anytime a text node was changed, if it was bold, they would just turn it back to not bold. And I was like, well, I can't think of why that wouldn't work, but not what we had in mind. But, so build powerful APIs and people do cool stuff with them. Listeners. So this is I alluded to this earlier when I was talking about transforms and why we needed them. Listeners are triggered generally in response to like an internal lexical event. One of the most common ones is an update. So as Lexical is performing the updates that you directed to perform, then once it's finished, an update listener will run and with the new state, and you'll be able to kind of like respond to the changes therein. And we have lots of other listeners as well, and they're pretty broadly applicable. The last thing I wanted to cover on core concepts was commands. So going back to kind of this thing, we have listen for events. Typically, you don't actually listen for DOM events. You actually would listen for a DOM event, or you would use one of our abstractions that does that for you, and then it would dispatch a command, which is our internal event system. And the reason you would use that is basically because you can use priorities to kind of intercept other commands, and override their behavior, and that kind of lets us keep a decoupled architecture while still letting you have that extensibility. So this is an example of commands. I think I'm going to run out of time right now, but this is so we'll probably won't have time to go through this example, but that's kind of more or less the gist. And if you have questions about commands or how to use them, then feel free to come talk to me afterward. And this is going to be a little embarrassing because I guess I went way longer than I was supposed to. I was going to give you guys a lot more about rich text here, but I'll skip to the thank you slide. And this is our core team at the top. All these guys are way smarter, and girls are way smarter, more talented than me. And they're really the reason why we're successful. And so, yeah, if you want to look us up on any of these surfaces, Discord's super active, Twitter, GitHub, feel free to make PRs. Really appreciate your time and attention.